A distillation system is designed to operate within certain predetermined limits. But when problems occur, efficiency and product quality can suffer. Operating a distillation system involves maintaining an equilibrium or balance between the rising vapor and the falling liquid in the column. One aspect of operation that can affect this balance is the system's feed rate. The feed rate is the rate at which feed mixture is pumped to a column. The flow of feed to a column can affect the quantity and quality of overhead product and bottoms product. For that reason, an optimum feed rate is normally determined mathematically based on system equipment and the materials being processed. An optimum feed rate is often determined when a system is designed and may be modified according to the mixture being distilled. However, a range within which the system functions efficiently is usually specified as well. For example, a system may have an optimum feed rate of 100 gallons per minute and an operating range of 80 to 120 gallons per minute. The way the feed rate is kept within the specified range depends on the system. In this system, a flow controller compares the rate of flow in the feed line to a preset value. If the feed rate needs to be adjusted, the controller signals a control valve to open or close. A distillation system functions most efficiently when its feed rate is kept within an established range. When the feed rate is regulated by a flow controller, slight variations in the rate can be expected. However, large variations can greatly affect a column's performance. If a system's feed rate is too high, overloading can occur. Overloading is a condition in which the vapor rising up a column is impeded by the liquid flowing down the column. For example, if the feed rate for this trade column is too high, the liquid will back up in the downcomers and build up on the trays. The increase in hydrostatic pressure restricts the vapor rising through the liquid. If overloading continues, more and more liquid backs up, and the rising vapor becomes severely blocked. This condition is known as flooding. While excessive liquid flow from a higher than normal feed rate is one cause of flooding, there are other causes. For example, a higher than normal reflux rate can have the same basic effect. Reflux is condensed overhead product that's pumped back to the top of a column. If there's too much reflux, the level of liquid on the trays can rise, increasing the hydrostatic pressure of the liquid and restricting or blocking the rising vapor. A column can also overload or flood if the temperature of the reflux is too low. A very low reflux temperature can cause too much vapor to condense in the column, which can overload the trays and impede the rising vapor. Excessive liquid flow down a column can cause overloading and flooding, but trays can also become overloaded because of excessive vapor flow up the column. One of the most common causes of excessive vapor flow is too high a temperature in the bottom of the column. If the temperature in the bottom of the column is too high, too much liquid is vaporized, and the vapor flow rate up the column increases. The increased vapor flow forces liquid up the column, flooding trays in an upward progression. If the problem continues, the pressure of the impeded vapor can increase to a point where it forces liquid out of the top of the column. This condition is sometimes called puking. When the vapor pressure is relieved, liquid flows back down the column, and the pressure buildup begins again. The surging of liquid up and down a column can sometimes damage internal structures of the column.